how to factor a special case called the difference of squares. And the nice thing about the difference of squares is if I can teach you to recognize it, factoring it is super duper easy. So I wrote down 3 problems here that all represent a difference of squares. I haven't explained what it is yet. We'll discuss that together. But what do these 3 problems all have in common that make them different from anything we've seen so far? There's one thing that's pretty glaringly different from them that they all have in common. Do you see how they're different from stuff we've done so far? None of them have an x term. They all have an x squared term. They all have a constant, but none of them have an x term. That's a big tell that we'll be doing difference of squares. The second thing that they actually all have in common is they're using numbers from this list of square numbers. Now maybe you remember what square numbers are. If you don't, I'll remind you right now, a square number is any number you can get by multiplying something by itself. Like the answer is a square number. So for example, since 1 times 1 is 1, 1's a square number. Since 2 times 2 is 4, 4 is a square number. This is 3 times 3. This is 4 times 4. This is 5 times 5, 6 times 6, 7 times 7. And of course I can go on forever like this. These square numbers are all over these problems. And there's this trick that says, look it, if you have something that's been squared and you subtract something else that's been squared, you can factor it by figuring out what you squared to get this. That would go here and here. And what you squared to get this. That would go here and here. And one will be plussed and one will be minused. This is a lot. I'm talking a lot of math theory right now. So what I'm asking you guys to do is maybe not get all the details down. I mean, if you can, great. But at the end of the day, here's what I'd like for us to understand. We're being asked to factor this. Holy moly, b is equal to 0. Probably square numbers are in play. Let's figure out what did we square to get this and what did we square to get this. So I'm going to write down some parentheses. I'm going to think, what would I have to multiply by itself to get 9x squared? What multiplies by itself to get 9 is 3 and 3. And of course, if this should be x squared, put an x on both. What would I multiply by itself to get 4? And that'd be 2 and 2. And then one's plussed and one's minused. And you'll notice that if you are good at foiling things out, you'll get a 9x squared, and you'll get a 6x and a negative 6x, and they'll cancel. So there'll be no x term, and you'll get a negative 4. So it'll work. This will multiply back out to give me this. Let's try the next one. Don't overthink this. That's the key. I notice that b is 0. So that tells me it's probably this difference of squares. So I'm going to just slap down some parentheses, and whatever multiplies by itself to give you this, that's going to go in the first half of each parenthesis. 4x and 4x would give me 16x squared. Whatever multiplies by itself to give me this is going to go in the second half of the parenthesis. Now, if you don't know, you can get a calculator out and you can use the square root button, right? So you can go square root of 49 and get 7. 7 times itself is 49. And then 1 is plus and 1's minus, and I'm done. Like there's almost no, the thinking's not so much in like all the words, the thinking is in recognizing the pattern and then using the pattern, trusting the pattern. For this last one, oh no, there's no b value. Cranberries. But I recognize this 100 is a perfect square. It's 10 times 10, and this is like 1 times 1. So I break it up into x and x to give me x squared, 10 and 10 to give me 100, and 1's plus and 1's minus, and that's all there is to it. We're just going to use this pattern, and when it's all said and done, if you're not sure if you're doing it right, take your answer and multiply it out. Take x times both of these terms, take 10 times both of these terms, and you'll see you get x squared. You'll get a 10x and a negative 10x. They'll cancel, so there'll be no x's. You'll have negative 100. If you're not trusting this answer, multiply it out. Do 4x times both of these. Do 7 times both of these. You'll get a 16x squared, a 28x and a negative 28x. they'll cancel, making no x's, and you'll get a negative 49. It's a great trick. We use this to be friendly and helpful. We want you guys to recognize this pattern. SAT and ACT love this pattern. They use it all the time. So if I can get you guys to recognize these square numbers and the fact that b having a 0 value is probably this pattern, that'd be awesome. So good luck, you guys.